What is a confidence interval? How does it work? A point estimate attempts to estimate a parameter using a single value. For example, P has an estimate of the population proportion, P. Likewise, to estimate mu, any mean, the population mean, we can use the point estimate X bar. So we're going to want to estimate this, we'll use X bar as our point estimate. A confidence interval attempts to estimate a parameter using a range of numbers. Instead of a single number, it is a range estimate. In the center of this range estimate, our statistic is a point estimate. Again, notice I drew this graph. You can read this. That means I meet the criteria that we just finished with. It's the sample size requirement to make sure we can draw this normal model. And let's answer the first question. What is the probability that a single p-hat value will be within 1 standard deviation of p? So here is p. What's the chance that I'll be within 1 standard deviation? That is, 1 standard deviation right here. Well, and I write this using function notation. What is the probability that, let's think about this, p hat is within 1 standard deviation, meaning p plus 1 standard deviation, or p minus 1 standard deviation to the left or to the right within this boundary. And the answer, I hope you'll recognize, is about roughly 68%. And that's all I care to do right now. This is not exact. We're going to get a little more exact when we calculate the confidence interval, but that's not exact, but it gives us an idea for what we're about to do. Let's think about it again. What is the probability that a single p-hat value will be within 2 standard deviations of p-hat? So all this means, instead of using 1 standard deviation, I'm going to use 2 of them. So now, what's the chance that my p-hat value lands between 2 standard deviations of this value, which is, again, unknown? And the answer is 0.95. Again, and that's an approximation. It's not exact. And we will use a more exact number later. All right. So how does this work? We're going to use this idea to estimate the parameter. And how does it work? Well, as I just mentioned, I'm going to use 95%. It's my starting point. We don't know where any of these values are. So right now I've marked 2 standard deviations on either side of this unknown value. But let's say p-hat lands right here. Now, what I'll do, and what's the chance of landing here? Well, it's within 2 standard deviations, so there's a 95% chance of it landing here. Then I'm going to create an interval that is pretty much, for practical purposes, nearly the same width as this. In other words, I'm going to use 2 standard deviations. If I did that, hope I can do this well. That's about that length, right? You'll notice, because I landed within 2 standard deviations, and there's a 95% chance of that following, if I create then an interval using this same length right here, voila, I will have captured the parameter. So the question becomes this: what's the chance that my p-hat value is within 2 standard deviations of the true parameter p? The answer is 95%. But then I'm going to turn this around. What's the chance that I will capture my true proportion? In other words, what's the chance that now p is in the center and now p-hat? And I'm going to use, instead of calling it using the symbol, because we can't use this one, as we'll explain, we're going to use a standard deviation, but it's not going to be that one. And I did mention that this one is just about the same length as that, so not exact. But what's the chance then that p is inside this interval that I've created, this one right here? And the answer is 0.95. Because since I said that this length is just about the same as that length, what is the only way that p is not inside this interval where this sits at its center? Let me draw another picture. And again, I'm going to try to mark these exactly the same. Okay, that's pretty good. You'll notice that if p hat lands outside of here, let's say it landed right here. Now what do? I create a little interval around it of the same length. So I'm going to try and create this of the same length, and that's about it. Then I'll come over here, try and do the same thing. So that's about the same length as this. And you'll notice when I create this interval, there's my target, my unknown. You'll notice I just put a big question mark on it because I just don't know what that value is. But as soon as it lands outside of that, I don't contain it. So the way this works is the following. We are going to create an interval. And not only are we going to create an interval, but I will be able to tell you our chance of success, which will be dependent on this number here, how many standard deviations I'm going to choose. Remember, what is this value? These are z-scores. That's what this value is a z-score. So we're going to choose an appropriate z-score to figure out how likely I am to succeed. What does succeed mean? Capture the unknown parameter. So this is just some unknown parameter, and I have, depending on what value I choose here for this value, the z-score, I can tell you the chance of success. So if I choose correctly, I could have a 95% chance of success. If I choose correctly, I could have a 99% chance of success. So we're a 95% chance of success. That's really good. I mean, that means that can I be confident that my range of estimates captures the unknown? And the answer is yes. I'm pretty certain. I mean, 95% certain. That's about all I can do. So that is how this works.